All right, so in today's video, what I'll be doing is sharing with you the process for fabrication. Last time, what we had was the design. What we do here is now create some fabrication notches here that are going to be useful if you're trying to use a CNC, and also how to deconstruct it and put it into sheets using OpenNest. I'll be going over all of the steps in detail. If you want to download the script, if you get lost somewhere, you can always do that on my website, capettidavid.com. You can download it until the next video is posted, and you'll be able to see the design and how it was deconstructed for fabrication. So with that being said, thank you very much for being here. Hopefully you're excited to learn a little bit more about fabrication, parametric design for architecture. And with that being said, let's jump right into the tutorial. All right, so at this stage we have the overall design. So if you haven't seen the video where I create the design, you can check out the full tutorial to see how this was created. Now what we need to do now is create some of the details that are going to be for here, creating some notches so that we can fabricate this correctly. So let's hide the top and bottom here for this, and then the left. And then let's get rid of the back side. And now what we're going to do is bring back this part. So we're going to take the parts where we moved one part forward and one part back. We can also hide these. Okay. Notice that when we move it forward the same amount as the amount that we move it back, now they're intersecting at that location. So what we need to do now is go to intersect, physical, brep, and brep. When we plug in both of those into the inputs, you're going to see, so we're going to take care of this down here. You're going to see that if we hide this, now we have some squares where they intersect. Now we do need to graft one side to get all of them. But once we do this, we can bring back the front and back, so the vertical and the horizontal ones. And for this, we need to, let's just bring back the horizontal ones. We need to create some subtractions for this. So what we need to do is take this and go to, we're going to start by doing it to 1. So we'll go here to list item. And we're just going to pick 1. So this is a grafted set. We're going to flatten this. We are now going to zoom in here and let's pick. Now we're going to explode this. So explode and pick one of these. Now we can do the same thing that we did earlier or in the tutorial where we use a point list, but we also need to get the midpoint of each one of these. So let's go to curve middle and then use a point list and then increase the size. So we can see it a little bit better. So we have 0, 1, 2, and 3. So that's how we have them organized. We're going to pick 0 and 2. So let's go here to list item. We're going to pick here. We have list index, set integer, or set multiple integers, but we're just going to be doing one at a time. So we have 0 and then copy this one. We're going to set integer and set 2. So we have 0 and 2. We're going to create a pipe So this is going to be, start with this one. The pipe is going to be relative to the 0. Caps are going to be flat. And then radius is going to be the, we want to do the diameter of your, what's it called, of your bit. So that's going to be, let's say 0.125. And it needs to be the diameter. So we need to divide by 2 because when the radius is 2 times. So if we divide this by 2, that'll be the radius. You could also, change this to 0.25 if your bit is a 1/4 inch. So now that we have this, we actually need to move it in the negative x direction. So we take this and we're going to move this in the negative x direction by the same amount as the radius here. Notice that it moves it this way. And we also need to move it in the positive y direction. By the radius. And so now we can use this move. So now that it moves here to in the negative x, we're also going to move it in the positive y, or in the negative y, because we're moving it the opposite of y. So now if we hide this, we'll end the original one. You'll see that we've created for this to move in this way and then this way. Now I'm seeing actually that this does not need to move back in the y direction. It only needs to do this. Why? Because the bit is going to come in here, but it needs to overcut to create this direction. So I take that back. You don't need to move it in the other direction. Why? Because we're basically subtracting this little bit. So it goes past a little bit and then it takes the next direction, and then we're going to do the same thing to this one. So let's copy. We actually have to copy all of this except for this. So we're going to be doing the same thing to this side, but instead of in the negative, it'll be in the positive x. Hopefully you see that the bit is now going to go past here. Okay. So now that we've done that with just this square, if we actually remove the flatten, you'll notice that it'll do it to all of them. So what we need to do now is, let's just pick the radius here. Let's say 0.25. Okay. So we have this and this for all of them. So we're going to bring those into not a group, a geometry component, flatten the input, and hide all of this. We can also disable the preview on this because that's only for us to understand how it's organized. And we need to do the same thing to so if we have the horizontal ones and that's what we're removing, we're going to also do a Boolean difference. So we can move all of this back out this way, because we already did a Boolean difference, but we did it with by moving this and moving this halfway in. So what we need to do is the same way that we subtracted from that, we're going to plug this into it. But we need to flatten the input. So what that will do is if we disable the preview here, you'll see that it will create a notch in all of them. So what we need to do now is we have the vertical ones completed, but if we look at the horizontal ones, now we need to do the exact same thing, but vertically in this way. So this is going to be in the positive. So this is going to be actually in the negative Z direction. Let's actually take care of that. So we'll bring in these. We have the item and we have the point list. We're going to be picking just one of these items. So let's go back to flatten here. Now we're going to go to the first one. We're going to use 1 and 3. So this is where we'll take this, copy it down, and instead of here being 0, this is going to be 1, and this is going to be 3. So if we look at the output, it's going to be creating the notch, but now we need to move it for the first one up in the Z direction. So it moves it up using the diameter. Now this one, as we can see here, it moved it down. So no, this has to be positive, and this one, it has to be negative. So now what we could do is flatten the input for, okay, so we're going to do this all at once. We've only done it to 1, but we need to flatten the input for this Boolean difference here, and then plug this, because it's going to do it to all of them, plug this into this one. Or let's just do it first here. Let's just go to remove the flatten, so it does it to all of them. We know it does that. Now we can hide the point list, we can hide the curve, we can hide all of this. And now we're going to subtract this from the verticals, which is this one. Now we can take this, hold down Shift to add another input and plug that in. Now we'll see that if we hide the all of this work, so this is going to be under the category of fabrication portions. So basically we're extracting where they intersect, creating a pipe for the horizontal ones and a pipe for the vertical ones, and those are going to be relative to your bit size. So this number actually needs to be consistent for both, unless you're using a different bit for cutting one or the other, but that wouldn't necessarily be the case. And now we have the vertical and the horizontal ones that if we were to take these two and bake them, now we can bring these out, and then you'll see that when you look at them, they look like there's nothing going on here, but when you bring them out, the bit is going to, let's see if we're able to do this. The bit is now going to go past the corner, come back around, and then come back past the corner here. And so when you intersect this and this one, they will bump at that intersection here, but they won't have any issues with you needing to come in and do an additional kind of fixing of where they meet, and they will meet perfectly. So if we now do a clipping plane, let's see, a vertical clipping plane. Let's see what this looks like. Just want to show you what this will look like at that exact location. Is this. So they'll be perfect for fabrication. So now that we've taken care of this, now we need to deconstruct all of this and put it into sheets. So we have the vertical ones, we have the top, you have the left and right, and then the top and bottom portions. We also have the back, so that's also something we need to look at. But what's great about this is that even if we change the number of subdivisions, let's say if we change it from 3 to 3, this will still remain and be able to be fabricated. So let's bring this back. And let's now focus on deconstructing this into flat planes here. So putting them right down here and then putting them into sheets. All right, so at this stage, we're going to take this and deconstruct it for fabrication. So what we need to do is I'm actually going to decrease the size of this. So this way it fits on sheets. Let's go back here and change the subdivisions. We'll just do 2. Actually, let's keep it at 3 and then just decrease the size so it would actually fit on a sheet. So 96 would be the largest, but let's just make it 60. Okay. So now that we have this, let's now go back to this portion and we're going to deconstruct it for fabrication. So what we need to do is how you would do this in Rhino without Grasshopper is you would make 2D. So we're going to take that same approach of flattening it using make 2D. And so first thing we'll do is go back to the overall form that was created with this one. And I'm going to bring in an area component. This will give me a midpoint relative to the entire design. So now that we have the midpoint, I'm actually hiding the wire display just because it just overlaps with everything. And then all we need is that centroid to create an XY plane. Now this XY plane is going to be our view for our make 2D. So when we type in make 2D, it's going to ask us for the view. So the view can be represented with a plane, and this plane is going to be looking down. So if we look at how this is organized, the bottom one would be the one that would work with this. So if we just wire display hidden, so this way it's a lot cleaner, and this is a different portion of the script, we'll plug in the bottom one. I'll go compute, and notice that it gives us the curves for the bottom side of this. Now, if we want to do the top side, we actually have to flip the direction. So I'll copy this down, go to flip, and then there's this component called flip plane. So we'll flip the plane to the other direction. We'll use that as the view, but now we need to plug in the top as the top portion. When we go to compute, you'll see that we'll get the top portion here. They're going to be overlapping for now, but we'll make sure that we'll go one at a time. So at the end, you'll see how that gets organized. So for now, we'll hide this. Okay, next portion is going to be the two sides. So if we bring in an X or a Y, Z plane, we can plug in the centroid into the origin. And now, since we put it up on this side, the view is going to be the left one. So we're going to copy this, use this plane as the view input, and start with the left. So this is going to be the left side. And if we compute it, we'll see that it will create the left side. We're going to do the exact same thing with the right side. So we'll take this, copy it down, override the YZ plane with the flip plane, and then use the right side to compute and view. And we see that these two are now overlapping, but those take care of the left and right. So what we did was create the midpoint, put a plane there, both in the X, Y, and the YZ, and then pick the views of each side and top and bottom to deconstruct them here. Now what we need to do is do the two verticals. So we're going to now go to the vertical one here, and this part's a little bit different because we need to take the verticals and move them in the Y direction. So let's go to the verticals. Let's do the horizontals first. Verticals first. Move them in the Y direction. But if we use a Y movement, it moves both of them at the same time. So this is where we need to move this one by 0 and then this one by more than 24 since the depth is 24. So using a series component, we're going to have starting at 0. So the first one's going to be 0, stepping by more than 24. So we'll just say 26. And how many? So we have 2. We can also just plug in the verticals to a list length. And list length is useful because as long as we flatten the input and we have whatever we have inputted here, it'll give us a number. So there's 2 vertical ones. And then when we have more vertical ones, this number will increase. So now we have count of 2. So the first one is going to be 0. The second one by 26, and it'll move the first one by 0 and the second one by 26. What we need to do now is the exact same thing for the vertical ones. So we'll double click, or for the horizontal ones, we'll double click in here because we know that that takes care of this output goes both into the list and into the move. The spacing is going to be the same. So now we can take this, slide it down, tap Alt, and create a copy, or you can do Control-C, Control-V, and do the same thing with the horizontal ones. So what do we need to do is the same thing that we did for these, but let's see, I'm just going to move these over here. The preview colors so they don't get in the way. And what's great about creating a script is that you can do your design and then do another portion for your fabrication. So like those are 2 separate distinct set of steps, but they intertwine for you to be able to change the design and then see the fabrication portion. Okay. Now that we have these moved out of the way, now we need to pick the direction. So let's see here. We need to create the XY So here we have an XY plane. This one's going to be independent and it gets put in the origin location. So now we need this one to be looking up. So we actually need to flip the direction because the plane is looking down. So we need it to look up. Then we're going to copy one of these and then just pick the horizontal ones. And now use this plane as the input. Now compute it and then preview it. So notice that we get those two, and those are relative to the spacing here. So if we have 24, they're going to be perfectly aligned, but we do need to recompute it. And actually it's going to be less because I think it's accounting for, oh no, so they do fit within 24. So our depth here is 24. Yeah, they still fit. Okay, that's good. Basically, this is going to be the spacing. So let's just change that. Now that doesn't really matter. It just matters that it doesn't overlap, because when they overlap, then you'll be losing one of the line segments that we need for fabrication. Okay, now let's go to a YZ plane. Same thing here. The YZ plane will be located against this one, looking this way. So we need to flip the direction. And we will copy this, use this plane as the input, and then view the vertical ones. So now if we compute it, you'll see it down here. And once again, they're overlapping. But we have basically taken care of flattening our information and putting it on the ground using Make 2D. So with this, now we can hide it. This is the center point. We can hide it. But this takes care of, once again, the fabrication portion. Now that we have these, I like to turn them into a surface. So we'll go here to boundary surface. So here's one. In particular, this one, because there are some cutouts on the inside. Now on this one, there will be some post-processing that is necessary. I was looking at this and the notches here, if we could kind of create that fishbone idea that we did in the vertical and horizontal ones, but you will actually see that. So on this one, the outside cut of the shelf is fine, but the inside here, there will be a radius. And so that does need to be post-processed from what I see on this one. And if you know another way of doing it, please let me know. I would love to kind of see how that can be kind of mitigated. Okay, we have all of these as surfaces. Now we need to put them onto a sheet. So that's going to be the next step. Because right now they're all overlapping. And so how do we take that and put it into some sheets? So I'm going to show you with OpenNest how to do that. So this is going to be OpenNest 2, and if you have Rhino 8, you should be able to access OpenNest 2 either by downloading it or yeah, I think by downloading it. So let's get into it. So now that we're going to fabricate it, let's first create a rectangle. This is going to represent the size of our board or of our sheets. So let's say we have a 48 by 96 or a 4 by 8 sheet. So this is going to be 48 in the X, 96 in the Y. Next is an OpenNest. You're going to see here a sheets component. We're going to plug in the rectangle into the polylines. And what's cool is that it basically erases it for you. Now copies by default, it has like a bunch of them. So let's just start with like 5 sheets. The gap is the gap between the sheets. So let's go here to 0.5. We can always adjust these. And then rows is going to be like if you actually want to create multiple rows of these. So let's just keep it here like this. Okay. I actually just like, oh, let's undo that. I just like creating the copies going this way. I mean, it doesn't really matter. This is just a more straightforward way of seeing how it's organized. Okay. Now that we have the sheets, we're going to bring in openness 2. And in openness, you're going to see geometry surface. The reason why we need geometry surface is because we actually have surfaces instead of curves. And this is so we can use, let's say on this one, where you have some inside cuts. So we'll plug all of these surfaces into the input. Holding down shift, we can add more than one input. So we've got the geometry here. We've got the sheets. So let's start by placing the sheet into the sheet openness 2 input, and then the geometry into the geometry input. And to get this working, we need to go to run and then bring in a toggle. So it's going to start by false, and then we'll make it true. So notice that we have 0, 1, 2, 3 sheets. So it's going to be 4 sheets because we start at 0. And it doesn't matter that these are overlapping down here when we did make 2D and turn them into surfaces, because it will just use one instance for each and place them there. So let's take all of this, and here we have the outputs. So I'm going to now create a curve. So this is not necessary. You already have the work here, but one curve for the sheets, one for the geometry, for all of the geometry. The sheet size. I'll take all of this and I'll actually hide it. And I'll take these two and move them out of the way. So move them in the X direction. So we can see all of the work here. So we're moving this in the X, and I'll just hide the wire display on this one because we'll do this exact same thing to sheets, and then hide this. So this is where it happens, and this is kind of shifting it to the right so we can see it. We can even shift it a little bit less. But notice that they're one right next to the other. So in this case, we're going to go to options, set multiple text, and in here, you're going to see all of the different parameters that you can change for your design and how it's laid out on the sheets. So number of rotations for this, 4 is okay. And it's going to be like how many times you can rotate the item to fit it into the sheet. So if we just said like 10, that it could do 10 rotations, you're going to see that it can actually start rotating it. but that doesn't give us the best result because we're creating rectangles here. So we actually want, under the options, we want the rotations to be 4. So 90 degrees, it can rotate it. The other thing we want to do under the options is go to set multiple text and then change the spacing to be 1/2 inch. So we'll do 0.5. And now those will be spaced by 0.5. So this is a way in which you can, let's go here into the next one, that you can also change your design. So let's say you want more subdivisions for this. So we'll just go here to 5. Let's say if it's a cubby for shoes. Well, now that we have that, we do need to recompute the vertical and horizontals for the side and for the top. And it's going to create as many sheets as it needs. So it's going to be doing 1, 2, 3, 4, 5, 6, 7, 8. And that's going to be relative to the vertical and horizontal subdivisions that we have. So and since it's too tall, it won't be able to fit on. This is like the most efficient way that you can do it. But if we go back here and we said, okay, the length, the depth, and then the height is 60. Well, let's just make this 44. Well, we need to go back and make sure we redo the make 2D portion. So that's one of the manual things that is necessary here. And compute and compute. And now, if it's going to be 44 inches tall, it fits on less sheets, and it will space them out by 1/2 inch. So let's now go back and let's organize some of this stuff, because this is going to be the bit size. Oh, and then here's the little cutouts because it's baked into the geometry. So this is going to be the bit size. This is not necessary because that's for the point list. This is going to be the spacing. That's correct. Although this is just necessary for it to clear it. And then over here, we're going to go X sheet, Y sheet, this is going to be the gap, gap relative to the sheet, and this is going to be number of sheets. Or copies, let's just do that. Okay, and then this is going to be like just shift. All right, so that concludes our tutorial. What we did today was create some fabrication notches on this one. We deconstructed it to flatten it. And then we put it on sheets using OpenNest. So if you got lost somewhere, or if you want to download this script, you can go to my website and download it for a limited time until the next video is posted. You'll get with this script the design for the shelves and also the portion that creates the OpenNest deconstruct to fabricate. If you have any questions, you can always let me know in the comments below or send it to my website. Hopefully you were able to learn a bit more about taking your design and fabricating it. This is in particular for this design. Other designs might take some similar steps, but might require a little bit of a different process. Overall, this is going to be great for those of you who are into fabrication. Thank you very much for watching. I hope to see you in the next one, and have a good day. Alright, so at the end here, I wanted to share with you guys the tool that I'm using for rendering. It is called ReRenderai.com, and it's an AI render that lets you take one of the captures of your design. So I just captured this image here, and I brought it in here. There are a lot of different options that you can choose, but what I like about it is that rather than spending a bunch of time rendering your item, applying materials, putting it in a scene, this lets you quickly visualize what it would look like within a space. So I understand some people are kind of against using AI, but I think this is a great use case for those of you who are into architecture. This is a simple render that I created with that same capture, and here are a few different options. So it's a quick way to visualize your design, and it's a great tool to give a shot. So if you want to try it, you can use the code that I have below. It'll give you a free trial, so you can give this a shot to see if it works for you. I just wanted to share with you guys this new tool that I'm using, and thank you for watching.